Hey guys, Mr. Backward here. In this video, we're going to look at derivatives of inverse functions. So if f is differentiable at every point of an interval I, and the derivative of f is never 0 on that same interval, then we can say that our function f has an inverse, and that the inverse of f is going to be differentiable at every point of that interval f of I. So if the inverse of our function f at a is equal to b, then the inverse function slope relationship relates the derivatives by the following equation. And it says that the derivative of the inverse of f at a is equal to 1 over the derivative of f at b. So in this example, we're going to look at evaluating a derivative of an inverse. So we've got the function f of x equals 1/4 x cubed plus x minus 4, and that function contains the point 2, 3. The first thing we want to do is we want to figure out what the value of the inverse of f of x is when we're using an x value of 3. So here's what we know. We were told that based on this f of x function being that 1/4 x cubed plus x minus 1, it's going to contain the point 2, 3. So what we could say about that is that f of 2 is equal to 3. Now, when we're looking at an inverse functions essentially undo each other, and one relationship that they have is that their ordered pairs are kind of backwards. So if we've got this 2, 3 point being on the original function f of x, then the point 3, 2 has to be contained within the inverse function. So we could say that the inverse of f at 3 is equal to 2. Now the next thing we're going to look at doing is finding the value of the derivative of the inverse of f at x when we're dealing with an x value of 3. Now I'm going to jump back a couple of slides to show that relationship again. So if we know that the inverse of f at a is equal to b, then as we want to do its derivative at that a value, what we want to look at is 1 over the derivative of your original f function at whatever that b value is. So in the previous example, we just said that the inverse of f at 3 is 2. So we know that the inverse of f at 3 is 2. So if we want to calculate this derivative, if we want to do the derivative of that inverse function at 3, then what we need to look at is 1 over the derivative of our original function f at 2. So looking back at our original function f, the first thing I want to do is find its derivative there. So f prime of x, if we look at using the power rule in that first part, drop the 3 down as a multiplier to the 1/4, and that becomes 3/4 x, and then we subtract 1 from the power, so that becomes x squared. And then if we differentiate that plain x in there, that just turns into a 1. And then if we differentiate the negative 1 on the back end, that turns into 0. So f prime is 3/4 x squared plus 1. But we're finding this derivative, so we want to do 1 over f prime at 2. So I'm going to take 2 and plug that in for x right here in the derivative. So we get 3/4 times 2 squared plus 1. 2 squared is 4. 3/4 times 4 is 3, but then we still have to add 1 to that, so that's 4. So we know that f prime of 2 is 4. So down here, we're going to get 1 over 4 as the derivative of our inverse at the x value of 3. So in this next example, we're going to be looking at some reciprocal slopes. So we're going to let our function f of x be x squared. Now we do have to restrict down the domain to being just x values that are greater than or equal to 0 based on the horizontal line test in order for the inverse to exist. So then the inverse of function f is going to be the square root of x. And we want to show that the slopes of the graphs of f and the inverse of f are reciprocals at a few points. And the first pair of points that we're going to look at are 2, 4 and 4, 2. So let's talk about this function f first, and let's find its derivative. So if I want to do f prime of x, I'm just going to use the power rule there, and that's going to be 2x. Now we're going to look at this point 2, 4. So if I plug 2 in here, well, we know that 2 times 2 is going to be 4. So f prime at 2 is 4. But now let's talk about our inverse function. And if we're finding slope there, we're going to have to find its derivative. So if we're doing the derivative of our inverse f function, we've got the square root of x, but I'm going to write that as a power. I'm going to write it as x to the 1/2 power, because then I can use my power rule. So I drop the 1/2 down in front as a multiplier, but then I have to subtract 1 from the power. And a half minus 1 is negative 1/2. Now, we don't typically like to leave our answers with negative exponents on them, so I'm going to take this x with a negative 1/2 on it and drop it down to the bottom of our fraction with that 2. So this is going to say 1 over 2 times x to the 1/2 power. But then I can rewrite that 1/2 power as a square root again. So I'm going to change this to say 1 over 2 times the square root of x. So that's the derivative of our inverse function. But now we want to look at using this 0.42. So if I want to find the slope there, I have to plug in that x value of 4. So this is going to say 1 over 2 times the square root of 4. Well, we know that the square root of 4 is 2, multiplied by that other 2 on bottom, and we're going to get 1/4. So we have verified that these slopes are, in fact, reciprocals of each other. Our function f had a slope of 4 at the point 24, but if we flip-flop those ordered pairs and make it 4, 2, and then look at the slope at the inverse, that was 1/4. So those are reciprocals of each other. Now, doing the exact same thing, but looking at a couple of different points, looking at the points 3, 9 and 9, 3, we already know that the derivative of our f function is 2x, and we're looking at the point 3, 9 for that f function. So if I plug in 3 there, well, 2 times 3, we get a slope of 6. And then we also know that the derivative of our inverse function was 1 over 2 times the square root of x. Well, if we're looking at that 9, 3 point, plug in the 9 there for the x, and we get 1 over 2 times the square root of 9. The square root of 9 is 3, times 2 is 6, so we get 1 over 6. And again, we can see that these slopes at those given points are reciprocals of each other. That's going to be it for this video. Thanks for watching.